Hi, my name is Chiedu Owemene, and in this video, I'm going to briefly describe at a high level my project for the BigQuery AI competition and show how BigQuery has helped me simplify part of my work as a music director at my church. So imagine you're the music director at a church, and your pastor tells you, hey, next month, I'm going to be teaching a series on divine provision. Could you please find songs for the worship team to sing that are related to that topic? So you start to look through your files, but nothing jumps out at you as being relevant to the theme divine provision. Maybe you even do an online search, but you don't seem to find anything that seems to fit the bill of what you're looking for. The challenge is that you're likely searching against song titles, but you're unlikely to find a song title that matches exactly the theme you were given. Like, it's unlikely there's going to be a song called Divine Provision, but those are the words you have to go by. That's what you're thinking about when you're trying to search. And another problem is that you might actually have a song that covers that theme, but that's not the title of the song. And those words aren't actually in the lyrics of the song, but the subject matter of the lyrics actually aligns with that theme. But you won't find those results because you're doing a keyword search based on those exact words. So this is where vector search comes in. Vector search goes beyond surface level keyword matching and finds results based on semantic similarity. So a vector is an array of numbers that represents an item. And these vectors are generated by text encoder models. And these numbers in the vector array actually represent the underlying meaning of the words, not just the text representation. So by storing text as vectors, a vector search can actually retrieve results based on semantic similarity. So I'm going to give a high-level overview of how I used vector search against my collection of song text files to solve this problem. So here are the text files containing song lyrics. I've converted them to just plain text files. They were RTF originally, but I just converted them to text to remove any unwanted formatting. I also named them in the format song title separated by a hyphen and a space and the artist or band name. And here's what an actual file looks like. You can see the title and then the lyrics. I've included the sections such as verse, chorus, bridge, etc. So the next step was to upload the files to Google Cloud and put them in a bucket. You can do this programmatically with a script or just by drag and drop. Once I had my files in a bucket, the next step was to create some tables in the Google Cloud console, in the BigQuery console. So I created a table for songs, and I created also another table called song lines. The song lines table was so I could also store individual lines of lyrics in a table so that I could be able to drill down to the line level of a song. Once I had my tables created, the next step was to write a Python script to process the files in the bucket. Basically, I read each file to extract the lyrics, and I parsed each file name to extract the song title and artist. After running the scripts, you can see the table is now populated with data. We have a song ID, song title, lyrics, artist, and created at date. You can also create an index for your table, but there is a minimum requirement of 5,000 rows to be able to use an index, which I didn't have, so I didn't need to use an index. The script also populates the song lines table. This is the table that drills down to the line level of each lyric. So you can see we have a line ID, we have line text, which shows the individual lines from the lyrics of the song. We also have a column for the section, like, bridge or chorus or verse for the song. Once the data is loaded, we can now create vector embeddings of the data. This SQL statement here creates an embeddings table by selecting the data from the song lines table and using the ml.generateEmbedding function to create embeddings of all the lines from the lyrics. So once you create the embeddings, this is what it looks like. You can see the line vec column with a lot of floating point numbers. Those are what the vector embeddings look like after we create the embeddings, the songline embeddings table. Now that we have our vector embeddings, we're going to run a vector search. Now this is how you structure a query to run a vector search. We're going to use the ml.generateEmbedding function again to embed our search text, which in this case will be divine provision. And we're passing this to the vector search function as a theme vec, which it was defined at the top of the query. We're also going to use distance type of cosine, which is recommended for text embeddings. For this query, we're just going to limit to 10 results, but that can be anything you choose, any number you choose. Okay, so let's go ahead and run our query. So we have some results. The first one says it is his will that every need be supplied. The next one says the Lord has provided. And the next one says you will supply El Shaddai from the song Overflow by Israel and New Breed. So these are actually relevant results. And to me, this is really powerful because even though they don't contain the words divine provision, they actually align with that theme. So this is really powerful, and I think it will be helpful for other worship leaders and music directors. So that's an overview of my project. Thanks for watching.